Hi guys, welcome to another video on calculus. In this video we're going to continue looking at differentiation. We're going to look at the chain rule, the product rule, and the quotient rule. Let's go. So the chain rule is used when we want to differentiate composite functions. So if we have a function in the form y is equal to f of g of x, if u is equal to g of x, then dy by dx, which is the derivative of y with respect to x, is equal to dy by du times du by dx. Now let's look at an example. So find the dy by dx if y is equal to 2x plus 4 to the 7th. Now a trick with the chain rule, how do you determine what should be your u? Whatever is being raised to the power. So like here we have 2x plus 4 being raised to the power. We let that be our u. So here u is equal to 2x plus 4. Now it's very important to pay attention to the formula. So du, we need du by dx based on the formula. So du by dx is just 2. So this is u. It is written in terms of x. So differentiating u with respect to x gives us 2. Now we're now able to, so the next thing we need is dy by du, right? So we're able to write y in terms of u. So y is equal to u to the 7th power. So remember 2x plus 4 is equal to u. So we can replace this with u and we get y to be equal to u to the 7th. So y is equal to, replace this with u to the 7th. So we're now able to find dy by du, which means we differentiate y with respect to u. That gives us 7u to the 6th power. So according to the chain rule, dy by dx will be equal to dy by du, which is 7u to the 6th power, times du by dx, which is 2. So we're able to multiply 7 times 2, that would give us 14, and you replace the u with 2x plus 4. That gives dy by dx to be 14. In bracket we have 2x plus 4, and that is being raised to the 6th power. Let's look at another example. So we want to find dy by dx if y is equal to 2 divided by square root of 6x plus 5. From a previous video, you should remember that whenever we have something, a function in this form, we always try to rewrite it. So rewriting, we have y is equal to 2, in bracket we have 6x plus 5 being raised to the negative half. Now I am sure you all remember, but since we are, the square root means we're raising it to a half, and since we are rewriting it and when we're rewriting the root 6x plus 5 in the numerator, we know that we change the sign of the power, right? So once again, what will be our u here? Our u is 6x plus 5. Remember, our u, we let u be whatever is being raised to the power. As based on how this is written, it is a 6x plus 5 that is being raised to the negative half, not the 2. The 2 isn't involved in that, alright? Now, du by dx is equal to 6. Y is equal to 2u to the negative half. So we replace 6x plus 5 with u, and we get dy by du to be equal to negative u to the negative 3 halves. And of course dy by dx is equal to negative u to the negative 3 halves times 6. So multiplying and making a substitution gives us dy by dx to be equal to negative 6 times 6x to the plus 5 to the negative 3 halves. Of course we can rewrite that, but we'll leave it here. Now there is an easier way or a quicker way for us to apply the chain rule. Alright, so we're gonna look at that on the left hand side. So dy by dx will be equal to So basically we apply that power rule, so we multiply by the power, so we have 7, we rewrite whatever is inside the bracket, 2x plus 4, we subtract 1 from the power, remember it's just basically the power rule, times the derivative of inside the bracket. So differentiating inside the bracket gives us 2. So that gives us 7 times 2. So we have 14. 2x plus 4 to the 6th power. Now I want you to go ahead and try that for example 2. Sorry about that. So let's go. Product rule. Now the product rule is, like the name suggests, we use it to differentiate products of x. So given y is equal to u times v, where u and v are functions of x, dy by dx is equal to u times dv by dx plus v times du by dx. Now what I like to say to remember this is dy by dx is equal to the first times the differential of the second, so that is u times dv by dx plus the second v times the derivative of the first, so that would be du by dx. So that's what I do to remember it, or that's what I say to remember it. But let's look at an example. So we want to differentiate x plus 2 squared times x cubed. So the first thing we do, we say we identify our u and our v. So u is equal to x plus 2 squared and v is equal to x cubed. So all of this here, first one is u, second one is v. So remember, we need du by dx, we need dv by dx, we need the derivative of both. So du by dx is 2 times x plus 2 and dv by dx is 3x squared. So we have all we need. So to find dy by dx, we need u, we have that already, we need dv by dx, we have that, we need v, already have that, and we need du by dx, which we already have. So now the rest is just substitution. So substituting would give us this. So substituting for u dv dx, v du dx, we have that. Now usually we try to simplify our answer as much as possible, so we are going to factorize. So looking at both, we have x squared being common, so we have x squared here, and we can get an x squared out of this guy here, and we have x plus 2 also being common. So we're going to factor out x squared and x plus 2. So factoring out x squared and x plus 2, it would probably been good if I made a square bracket here. So factoring out, we factored out x squared and x plus 2, so we have 3x plus 2. That would be what we get from here when we divide this here by x squared times x plus 2, and we have 2x. So dividing this here by x squared x plus 2, we're left with 2x. And we can simplify, so we can expand here and simplify inside the bracket, and we would get x squared x plus 2, 5x plus 6. So that was our application of the product rule. Now we're going to extend the product rule a bit, and we're going to consider y is to be equal to u over v, or u divided by v, where u and v are both functions of x. So we can rewrite this as a product. So y is equal to u times v to the negative 1. So we want to find the dy by dx, so we are going to apply the product rule. Now remember that the product rule says the first times the derivative of the second. So it will be u times derivative of v to the negative 1. So we multiply by the power, we subtract 1. So that's minus v to the minus 2. Now, if you recall from earlier in the video, whenever we have a function, we have something being raised to a power, or some function being raised to a power, we have to apply the chain rule. Remember? Yes. So that means we would need to differentiate the function v, and differentiating v is just dv by dx. So we have v, it is being raised to the negative 1. So applying the chain rule, we would have negative v to the negative 2 times the derivative of what's inside the bracket. We don't know what the function, so we just call it dv by dx because we differentiate it with respect to x. Alright, so that's what happened here. So still working with the chain rule, plus the second, which is v to the negative 1 times the derivative of the first, so times du by dx. So now we simplify. So dy by dx is equal to minus u times dv by dx divided by v squared. So this v to the negative 2, we just tuck that under in the denominator there. Plus, similarly, we write v to the negative 1. So that's just 1 over v, right? I'll multiply it by du by dx. So we have du by dx divided by v. So now we're going to use our knowledge of fractions. So we're adding these guys. So we find the LCM. The LCM is v squared. So dy by dx is equal to minus u times dv by dx divided by v squared plus, so v squared divided by v, that would be v, we multiply this here by v, so we have plus v times du by dx. And we can rewrite it so we don't have this negative sign at the front, and we get dy by dx to be equal to v times du by dx minus u times dv by dx, all divided by v squared. Now this here is what we call the quotient rule. So now we're going to look at how we apply the quotient rule to differentiate functions. So we want to find the derivative of y is equal to x plus 3 divided by x squared minus 6. So we first identify our u. Our u is the function at the top. So remember, y is equal to u divided by v. So u is the function at the top. So u is x plus 3. And we're going to differentiate that and we get 1. V is equal to x squared minus 6. Differentiating that gives us 2x. Now just a reminder, the quotient rule says dy by dx is equal to v times du by dx minus u times dv by dx, all divided by v squared. Now once again, as before with the product rule, once we're at this stage, it's just substitution. So substituting gives us that, and then we simplify. So just a reminder, question that I'm asked a lot. So we expand here. So 2x times x, that's 2x squared. 2x times 3, that's 6x. We distribute the minus sign, so it will be minus 2x squared minus 6x. Alright, just a reminder. So simplifying that, and we get dy by dx to be equal to minus x squared minus 6x minus 6, all divided by x squared minus 6 being raised to this second power. Now usually we don't expand the denominator. Usually we just leave it as is, and this would be our answer. So this concludes today's video, or this video on differentiation. So we looked at the chain rule, the product rule, and the quotient rule.